I want to talk about a project that we're doing on Cyberinfrastructure Facilitators. And there's the picture. Raphael's back. I believe it's a fresco. And actually, it's an interesting image because it's the idealized image of the academy, which I always like to say was Plato's gym. The YMCA of his day was where knowledge was created. And what I love about it is, here are all our natural philosophers where their equipment that they needed to do their work was whatever they were walking around in. And clearly, as science has evolved, the tools and mechanisms and the depth of the knowledge and the background they need has evolved and changed as well. And yet, what's interesting is we still, in some ways, maybe not the robes, usually the robes with the tassel, we retain this as an image of sort of the ideal way of doing science. And so we look at the idea of the individual scholar and the individual scholar on their own as being the ultimate, and the idea of them not knowing the full extent of the work they're doing, I think, often gets in the way. I'm just repeating a lot of things that I've heard today. The project I want to talk about, this is a National Science Foundation in the U.S. funded a project on CI-Facilitators, accelerating knowledge development and collaboration across STEM disciplines, science, technology, engineering, mathematics, though we certainly feel that it has broader application to the humanities and social science. However, NSF had a bigger checkbook at the time. And the project is to develop three things. First, to design an educational program, including internships and technical training, standalone learning modules in facilitation. What we're really looking at is how can we prepare a professional that is going to go in and work with scientists and work with scientific teams to really help them take access to this technology. What we're stating here is something that came up in an earlier session. The belief that somehow we're going to train experts that have very deep subject knowledge, whether it's in physics or whether it's in literature, to now be experts in literature and cyber infrastructure and every new technology comes out is just impossible. It's just to the point where they can't keep up, and the expectation is going to be such that if we require this, particularly if we're talking about changing practice, but we want faster adoption, we're going to need to jumpstart that process. So, how do we design an educational program to prepare these facilitators? Then we need to prototype this by creating a cohort of master's degree students who will be part of a 2-year graduate level certification program, and then finally do revision and evaluation. I should say that I think day one of this project started yesterday, so we won't have a lot of results for you, but I do want to talk a little bit about what's going into this process. Also, I'll be talking about results from a project that's been going on now for about 3 years on participatory librarianship with the American Library Association's Office for Information Technology Policy, my research institute at Syracuse, and a couple of other projects along the way. And the role of this project is really to be looking at future of libraries and librarians and democracies, and really looking for what is a deep conceptual framework for navigating that future. My background and where I do a lot of my research is in libraries and information organizations, and they're facing an issue about where do they go next. And I think one of the issues that came up, this started with a discussion of Web 2.0 and social networking. As libraries and really as the U.S. Congress was wrestling with what is a social network and what are social media sites and what should we do about it, how do we define it, we began looking into that because libraries would be facing it as well. And we really began to say this isn't just a set of functions. There's something going on underneath here. There's really a change in, change online, but I think really catching up to how human beings learn, and how does this impact how we organize and disseminate knowledge, looking in this case at libraries. So what am I going to do this afternoon? Well, I'm going to talk a little bit about what I mean by what is a CI facilitator and talk about a need for frameworks within that role. Posit that in a context of massive scale information, and finally talk a little bit about how that framework plays out. So starting with how am I defining cyber infrastructure? It's a term we throw around a lot, but here's our brief definition. It's a broad term, including webs, wireless grills, parallel grids, parallel processors, laptops, cell phones, mainframes, telecommunications. If you can plug it in, it's probably part of cyber infrastructure. The reason we go that broad is that I think a lot of people look at, when they talk about an infrastructure, they assume, that's in Internet 2, or that's this fast backbone, or that's the TerraGrid. And yet, when we look at it, the true impact of technology has been in people using email back and forth, in people being able to share data sets with FTP in the web. And so really, that's where we've seen a massive uptake of technology and use of technology in e-research is in the basic day-to-day stuff and not necessarily in the very high-end facility, and it needs to be incorporated. So then what do we mean by a cyber infrastructure facilitator? It's one who then aids the research of topical experts to utilize this infrastructure. Really what we're doing is we're positing a model, once again, not positing, we're recognizing the team model of research where you have someone who understands a topical area very well or has a team that's working in really deep understanding of a given field, and this person is going to not try and replicate that knowledge but know enough about it that they can then help them utilize the terms. Everyone has their story of, that wonderful thing that, if they only had known, right? Some of them are disastrous, such as, medicine studies where if they had looked up this other study that showed the fatal interaction 2 years ago, they could have prevented catastrophe. I've worked in the transportation industry, will come up again, and there's a classic study about how the U.S. is spending a huge amount of money in resurfacing roadways when a European practice and how if they just add this sort of mixture to concrete could save them several $1 million a year, and all it required was a quick search. And so if we can have people that can do this kind of work, that would be helpful. In fact, in librarianship and special librarianship, this is pretty often the case where you look at medical librarianship where the librarians don't sit in the medical library, they're going on rounds with the doctors. They're sitting, the Department of Justice doing some studies where they actually sit on prosecutorial teams. There was an interesting discussion, so I'm in the Department of Justice and they're talking about how they love their libraries, and one of them were, if you're on the prosecution side, what you can do is you can call up the Federal Bureau of Investigations and they'll bring their guns and such and rough people up and go gather data on the street. On the civil side, they have no such advantage, so they actually use their librarians. They don't yet give them guns and badges, but they set them online to go and become, in essence, the investigation arm of their teams. So how is this going to work in e-science? Well, we started by figuring out what do we need to be teaching these folks, and really this is more posed as a question to you in the midst of this, but this is our starting point. We looked at the occupational databases in the U.S., what's called an ONET, and we looked at several fields that we felt were collaborative and looked at the kinds of skills that they would need, things like English language skills where we are, computers and electronics, but customer and personal service. High collaboration, and what are the kinds of skills that would be needed for these types of facilitators? Science and math skills, administration and management, education and training, and then some of the tools and technologies they would need to get. We followed that up with a focus group with several PIs and asked them, what are these kinds of skills? And once again, this was what came out of that focus group, that they really needed someone who had some knowledge of the domain. Once again, this is the STEM group, so it's very much towards the science side. But we've seen this, for example, in medical informatics, where we trained all these people on the informatics side. They went into medical settings, and they said, and your MD is in what concentration? And they looked at them and said, I don't have an MD. And they said, that's very nice of you to come, and completely dismissed them. And the idea is, what is necessary to get on that team? There really is, what's that necessary knowledge? In architecture, operations, and data networks and information policies, but once again, human-computer interaction, scripting, and programming languages. Nothing terribly striking here. Now, the reason that I want to talk about frameworks, there is the classic story of the three blind mice and the elephant in the room where they all sort of grab a different part of the elephant and decide whether they have completely different animals. And the reason, if without frameworks, you have a hard time understanding what's coming up and what's next, that in fact that is an elephant. And if you add those together, you understand how that elephant sort of fits in the whole world. The reason I bring this up is, if we're going to make very technically competent people go in and talk to very focused and experts in their given discipline, it's going to be very easy for them to constantly try and ramp up new skills, which are going to get out of date. We've all dealt with this. So in fact, what we really need to do is not concentrate on getting people out that understand, the latest in the Java programming language and the latest in the grid terminology and the latest in this. What we need to get out are people that have that basic skills but have a larger perspectives that they can bring to these different technological fields. Because right now in the cyber infrastructure world, we have a lot of blind mice and a lot of, I think, different elephants wandering around bumping into each other. This is a wonderful web trends map talking about the different sites and how they're cool. So you get Google over there, and it's mapped onto the Japanese subway structure, which is even more fun. I would hate to have to find a way around quickly in there. This is the situation that we're often facing, which is that we have facilitators and we have organizations, and when they look at this possible range of different applications, they go cross-eyed, they go blind. So if we can't provide them with a given perspective and a way of sort of encountering and determining importance of new tools and balance of new tools, they will constantly be chasing new tools, and we will produce something that is not very helpful in terms of a curriculum, in terms of a professional. Now, the other problem that they're facing, that we face in preparing these folks, is not just which tools do we teach them and what's the need for the larger framework, but clearly they're going to be working in a world that is very different. So I've worked with the National Academy of Sciences in the States on transportation information management. And we were in the process, and what we did is we got a lot of information professionals, and a lot of them came from departments of transportation throughout the states. And a lot of them were in highway management and environmental science, and they were usually in the libraries, and they were all spending their time worried about what metadata schemas do we use, and can we deal with ontology here, and do we need OAI repositories, and really intricate things like should we put our collections in WorldCat. And we were having this wonderful discussion, which frankly made me go cross-eyed, until we realized that we were really dealing with a drop in the bucket. That out of the transportation field, soon every mile of road in the United States will generate a gigabyte of data per day. Every mile of road will have not only the cars that go on them and toll information, RFIDs and car boxes, and of course if you're in Europe, there are, I think, closed-circuit televisions every 5 feet. It's very interesting when you're in the United States and you believe you live in a police state to come to Heathrow Airport and realize what observation really means. That we're also to the point now what they're talking about with a lot of them worried about environmental impact is the idea of putting RFID and minor sensors right into the pavement so that instead of salting the roads whenever it gets a little cold, which in Syracuse, New York is kind of often, they'll have temperature sensors that they can sort of radio in and say, I'm frozen, come salt me, and can really begin to control the way that these different materials get utilized. It's assumed that this gigabyte an hour will become gigabyte an hour. Since there are 3.5 million miles of highways in the U.S., that would be 3.3 petabytes of data per hour, or 28 exabytes of data per year. Now, this is not a group that I need to spend a lot of time saying, look, there's lots of stuff coming at us. But when your roads are generating that, we really have an issue. And by the way, what's interesting about this, in the States we have RFID toll systems, and in New York it was a big debate about putting them up so that we could drive through quickly and not have to stop and drop money into them. And people said, oh, this is great. And it turns out that one of the number one users of this data is actually divorce lawyers who are trying to find out where your spouse was on Friday night. So what are the options when we talk about this? So I'm going to use this from a perspective I spent a lot of time to in library science, which is if we take this sort of framework and technology of library science and apply it to this e-science data world, we have a couple of options. One, we could catalog it all. We tried it. It didn't work. It's not going to work. We'll come back to that in a second. We could ignore it. I personally like that one, but that's why we come to Oxford. We can limit the things that different institutions do, so we can say, oh, that's e-research, that's not what libraries do. Or we can ultimately embrace it, and I would argue that's what we have to do. But to embrace it, we must realize that this is a really different world that we're going to. And that is that a lot of data curation, when libraries have done data curation in the past, they've really looked at documents. And in fact, if you look at the ethics that come out of libraries, and you look at everything from the American Library Association, IFLA, and their new IFLA model, it's all about documents and recorded knowledge. The problem is, as we migrated from documents to digital documents, some things happened. The first thing that happened is that traditional terminology becomes metaphoric. That when you talk about a document or a collection, you don't actually talk about a document or a collection. You're talking about document-like things, collection-like things. In fact, the Dublin Core was phrased as dealing with document-like objects. Well, that's one thing that happens, because they're just ones and zeros, and how we break them up and how we parse them is different. And so when we go to apply, we'll talk about this in a second, we began to append prefixes, which is well, it's not a journal. It really wants to be a journal. All right, so far we can't call it a journal. We'll call it an e-journal, right? It's a book, but it's not really a book because you can do it's an e-book. And finally what happens is that the document model completely breaks down, and we have to face facts that we are no longer in a document-oriented world. Two examples of that. The first, sort of dismal failures of applying document-like terminology and things to a non-document-like world is Quark. Some of you probably never heard of Quark. Oh, 3 minutes? And then move. Collaborative Online Resource Cataloging in OCLC, what it was is you got to pay them to do MARC records for online websites, seen as Google just estimated that there are 1 trillion web pages out there. If we took 65,000 members of ALA and gave them a minute to catalog them all, it would only take them about 29 years. The other one is the National Science Digital Library. And the National Science Digital Library had this great theory. They said, we're going to build a wonderful resource for STEM resources in the United States, and the way we're going to do it is we're going to pay some people to be collection builders. They're going to go out and get stuff in a topically oriented way. So you're the physics group, you're the chemistry group, you're the mathematics group. Go and build us a beautiful collection. And then over here, we will fund a bunch of services. So you'll do the search for it, you'll do the visualization, you'll do the archiving for it. And don't worry, in the middle, here comes a little magic, we'll build a group called the Core Integration, and they'll make it all work together. Well, the problem was that all the collections started building their own resources, and they said, well, I've got all this great collection in physics. I need to put that on a website, right? Yes. Well, if people want to navigate it, I might as well put, some categories so they can go, oh, and how about a search engine? You need to search it. And so what happens is they began building a service. And so the service people showed up and they said, well, where's your metadata? And they said, well, we don't use metadata, we don't need it. Or here's our metadata, but it's not in a format you can use because it's what we need. And the services could no longer talk. Well, what the true discovery of that project was, excuse me, is that a digital library is a collection of services, only one of which is access. That the concept of being a collection builder doesn't really make any sense in a digital world. What you're doing is you're building a set of services. One of it may be access to documents or document-like objects, but ultimately you're building services. So if we can't use this sort of traditional cadre of document objects, we can't say we're going to produce a large images and we send out these facilitators and we say, here's your tool set. So what you're going to do, how many of you have been at these meetings? What you're going to do is you're going to walk into a research team, you're going to discover the language they use, you're going to build a taxonomy or ontology, call it what you will, and then what you're going to do is apply metadata to everything they produce and put it online. It'll be easily searchable. Well, that's great, except that in research we're discovering new things, and it turns out the terminology is really squishy and not universal, and frankly is irrelevant by the time it hits a publication. And the kind of materials that are really useful to people are either highly synthesized documents at one end or completely formative documents at the other, and so therefore figuring out an archive and preservation process for dirty data, which is now more process-oriented than finalized, isn't going to work. And so this is where we begin to bring in this notion of participatory librarianship, which reminded me very much of this first meeting, so I'm going to run through it. But that's the idea that this comes out of something called conversation theory, a fellow by Norma Gordon Pask, who's a cybernetician, talked about that knowledge is created through conversation. That theory, that conversation is scalable, where it can be a conversation of two individuals, multiple organizations, or within a single individual, quiet reading in the corner, if you will. And so what happens is that artifacts are produced are simply byproducts of these conversations. We know that once we hit an item in a journal, it really is an archival state of a lot of conversations that went into that. Amongst myself, among my research colleagues, among the discourse communities, that conversation is the real process. And what digital and e-research is allowing us to do is to catch up to the conversation, to get closer to the point of knowledge creation, and farther we can get to the synthesized endpoint, but it's much more interesting to work in the in-betweens. And how does this help us begin to deal with things like massive scale data? Well, let's take a scenario where a researcher goes to their librarian and asks a simple question like, did it rain on June 18th in Yellowstone National Park, which has some really remote areas that doesn't have a weather map next to it? And so this librarian will go and consult a meteorological model who will then say, yes, it did. Well, the person can go back and say something to the effect of, well, how sure are you? Since you weren't there and it wasn't raining on your head, can you tell me for sure that it rained? This user says. Well, to understand that, to quantify uncertainty, we really need to understand what that model was based on, including what data came into that model from distributed sensor grids, from satellite, from images. We still throw balloons up into the stratosphere. And we also need to understand that the model itself is a product of an ongoing research process, which itself is a conversation. And so to really understand our level of uncertainty, we must relate it to terabyte data sets. We must relate it to different outcomes, different individuals, different conversations. Now, you say, well, why do I have to go to that extent? Because we don't necessarily understand what the context of our user was. Well, let's say that user wasn't a researcher, but was in fact a lawyer who was filing a brief. And that brief was part of an accident, where the plaintiff had said, I was wet, I was driving, I skidded, I broke. And now I want my insurance company to pay me, and the insurance company says, no, that's not good enough. Well, this is actually going to become official documents. But now what we've also done is we've linked distributed sensor net data of terabyte scales into legal documents of context. We've crossed context together. Well, if you begin to apply traditional document-like descriptors, what's the MARC record for the terabyte meteorological data set, and exactly where in MARC does it mention legal information, and how do we cross-reference it over to legal information, because Library of Congress classification doesn't do that so well? The answer is you don't. You keep it as a conversation. You make this knowledge explicit. You were talking about the idea of knowledge being a series of contexts and how we relate things together. It's the relationships between the objects that becomes much more important in a digital context than the objects themselves. That when we look at that data set, you mentioned the idea of it's not the fact that I think my data is perfect. I thought that was great. It's just I know where the crap is in my data. The point of that is I should be able to represent that in some way. And that it's not necessarily even the end result. I want to know the context. This is great data in this context. This is great data in this context. This is sufficient data in this context. It's all about context, which is all about conversation, which is all about relationships. And if we keep trying to run people through this strainer of document-like objects and end results and containers that can be represented without context, we run into really big problems. One of the issues with having other people apply metadata to my objects is they don't know the full context, so how can I trust it or not trust it? So with that, I will just leave some follow-ups. If you're interested in more on participatory librarianship, ptbed.org, and there's some email for my co-authors who will probably have will want to know if I screwed this up royally. So there you go. Thank you.
I'm not sure I understood well the concept of participatory librarianship. I'm wondering, is just having like a thread of comments and questions under a digital object in the digital library, or are you thinking including like tags?
This is interesting. Let's talk about tags for a minute, taxonomies. Because tags are a great example of how storing a conversation is different than dealing with things as a document. If I gave you a picture and asked for a set of 10 tags, you could give them to me. Not a problem. If I showed up 3 months later and gave you just the list of tags and asked you to tell me what it was describing, you might actually have a very hard time. If I showed up a year later, you'd have no idea. So in fact, tags are temporal. We know that they're temporal, and yet we represent them like they're not. And so when we talk about associating them with an object, does that really help us? Well, it does if you aggregate it, and it has some interesting social aspects. If I ask you to relate that image to another image, and to another image, and I show you the relationships, you can usually fill in what are the different things. So it's really a matter of storing relationships among objects. A conversation, in terms of a verbal yes, no, here we go, is one way of representing those relationships. But we can do them in other things like concept mapping. You can do them in resource mapping. And so what we see is we see a lot of application of, I have a bunch of data sets, let's put metadata on each data set. And we forget the fact that we actually need, and then, a collection level metadata set, and then we need a metadata set. And what we begin to do is you end up with 10 gigabytes of metadata to 1 kilobyte of data. And the reason is because we're trying to cram every potential context ever that could be thought about that one object ever. And what we need to be doing is saying, here's the context for the object, and if you build another context, you must make explicit links within it. And we've seen in the search engine world, this has had major effect. In the search engine world, Google's major transformational effect on search engine information retrieval has been moving away from document-like metrics to network metrics, meaning it used to be, can I find that term? How often do I find that term? What's the term? In other words, everything about a document. And what Google said is, look at all of this relational data I have on the web of who points to what, and now I can use PageRank, which is going to show its relationship to other things. And it turns out that relationship is an amazingly good surrogate for things like relevance and such. And that's the kind of shift we also need to make in how we organize our materials.
Can I ask something? Participatory librarianship, how does that fit into the educational program that you're building now, and what does that consist of? I mean, in other words, what makes cyber infrastructure facilitation different from a library information science education? Can you say a bit about that?
Certainly. The answer is that there are going to be lots of different ways of skills that the cyber infrastructure facilitators are going to need to take away. Some very technical skills, some large concepts. Those concepts are going to be including from other authors such as collaboration and collaboratoria and some of the work coming out of cyber infrastructure from Derek Cogburn, for example. Some are going to come out of work from cognitive psychology and data security. So there are going to be lots of models, one of which it's going to be to the group to sort of churn and see what it fits. It's going to be participatory librarianship. When I look at the idea of an information professional whose job is to facilitate research, that fits in many contexts, one of which comes out of a library science tradition. And there are things that we've learned that should go into that. But that's only one. So this is not, I'm not positing this as this is the central thing that we must understand. But it is, I think, one thing that we need to understand, which is I need to understand the technology. I need to understand the problem. First of all, I need to understand the problem you're trying to solve. Some technology I can bring to it, but I also need to understand data management practices. I also need to understand what information do I need to keep and when, and the fact that that may come from multiple contexts. And there, what my big push is to try and avoid, those are a bunch of documents. I just need to organize documents together, because what you'll end up with is hard drive after hard drive full of document after document that doesn't mean anything. You mentioned the idea of the fossil. Take these hard drives out in 10 years, if you could read the data, would you really know what problem they were trying to solve? You need that context and that fitting together. So, I'm going to steal all of your good lines, Maria. I'm sorry.
Excellent. Can we thank a wonderful, wonderful panel?